Welcome to Get Your FRQ On. This is from the 1999 exam. It's question 2 and it is calculator active. In the question stem, we define a region R as the region bounded above by the line y equals 4, bounded below by the graph of y equals x squared. And in part A, we are asked to find the area of the region R. In the question stem, we're not given what the bounds of the integral would have to be, so we have to find those ourselves. And in order to find the bounds of the integral, we have to figure out where the two graphs intersect. Right? So the area of R can be found using a definite integral, but we need to know the bounds of that integral. And to determine the bounds, we have to solve the equation x squared equals 4. Fairly easy enough. The solutions to that equation are x equals -2 and x equals +2. Right? Using that information, the area of that region would just be the integral from -2 to +2 of the upper function 4 minus the lower function x squared dx. All right, so if we set that up, that's going to be 4x minus 1/3 of x cubed, evaluated between 2 and -2. This is a calculator active question. You are more than welcome to use your calculator to do this. I enjoy doing the calculus though, so I did it by hand. And if we do this, 8 minus 8/3 minus -8 plus 8/3, we get 32/3 as the area of that region R. All right, so if you use your calculator to do this, or if you just know that 32/3, figure out a decimal for that. The area from -2 to 2 of 4 minus x squared is 10.667. In part B, we are asked to find the volume of the solid created when this region R is revolved around the x-axis. All right, now the volume when R is revolved around the x-axis is going to be pi times whatever the radiuses are going to be. So we have our outer function, which is the upper bound, that's y equals 4. That big radius is 4. Our small radius is the underneath function, the lower function, which is x squared. And basically we're just taking the area of two circles and subtracting them as we integrate. So our integral is pi times the integral from -2 to +2 of 4 squared minus x squared squared dx. It's a calculator active question. I like doing it by hand, not that much. So if we plug this into our calculator, we find that the volume of that solid of revolution is about 160.850. In part C of the question, we are supposing a value of k greater than 4. If the region R is revolved around the line y equals k, such that the resulting volume is the same as it was in part B, write an integral equation that could be used to solve for k. All right, so really what you want to think of here is you want to visualize what's going on here. We have a value of k greater than 4. And so we have this horizontal line. We're going to be revolving around that line. So one of the things we can do is, well, what would the volume be if I just revolved all of that region all the way up to k around the line y equals k, and then, since k is greater than 4, there's like a disk in the middle that I would have to take out. All right, that's two fairly simple integrals. So the volume of the solid, if we just ignore the fact that part of it, we're not going all the way up to k, we're only going up to 4. If we ignore that fact temporarily, the volume of the solid generated by revolving around the line y equals k down to the graph of y equals x squared would just be pi times the integral from -2 to 2 of k minus x squared squared. All right, that would get us the volume of this like giant disk with parabolic edge to it. All right, the volume of the solid between the line y equals k and the line y equals 4 can be found using the integral pi times the integral from -2 to 2 of k minus 4 squared dx. And so if I want the volume of this solid to be the same as the one in part B, which was 160.850. What I need is 160.850 to equal pi times this big chunk, the big, huge, solid minus the little disk in the middle. So we need that to equal pi times the integral from -2 to 2 of k minus x squared dx minus pi times the integral from -2 to 2 of k minus 4 squared dx. That might be good enough to earn all the points for this part of the question. If not, we're just going to combine this into one integral, and that would be pi times the integral from -2 to 2 of k minus x squared minus k minus 4 squared dx. If you have both of those, I don't think you'd have to worry about which one is going to be acceptable, or if they'll both be acceptable, or if one of them isn't going to be acceptable. If you have the first one and you simplify it into the second one, there's not really any math you have to do here. You just have to combine the expressions into a single integral, which is totally okay to do. And then that would be the integral that you would have to set up. Notice, the question here is asking you to write an integral equation. It never says to solve this. All right, so all you have to do is come up with the correct integral equation that you would need to solve. You do not actually have to solve this, and that would complete part C of the question. And I believe that is the end of this question.